All right, this video is going to talk about trig identities or trigonometric identities. And basically a trig identity is just a true statement. It's much like a property in algebra, things like the commutative property or the associative property, things that are true all the time. So trig identities, the most basic of which would just be essentially the definitions of the trig identities. So the sine of theta equals the opposite over the hypotenuse, or the cosine of theta equals adjacent over hypotenuse. The basic SOH-CAH-TOA idea would be trig identities. So let's start off by filling in the sine of theta, cosine of theta, and tangent of theta down here at the bottom of the screen for this example in the middle of the screen here. Now, one thing we're going to need would be the other side of this triangle. We only have the hypotenuse right now, right? The side opposite the 90-degree angle. And the adjacent, notice where theta is up here, we only have that adjacent side. So we need to know what the opposite side will be. So let's go ahead and find that. Remember, with a basic right triangle, the Pythagorean theorem is your fastest way there. So we can just say 4 squared plus, I'm just going to call it b squared. Doesn't really matter what letter you call it, equals 6 squared. So again, if we take that 36 on the right and we subtract our 16, b squared will be equal to 20. And basically the bottom side here would be the square root of 20. Or if we simplify it a little bit, remember that 20 is really 5 times 4, so the square root of 4 would have been 2. And again, that square root of 5 gets left behind. Don't go find the decimal. Again, we're going to be setting up some ratios, so we're much better off with that exact value than we are with any sort of a decimal value as far as that side length goes. But now we can simply set up the sine. So sine being opposite, 2 root 5 over hypotenuse, 6. And you'll notice again, there's a 2 on the top and a 6 on the bottom. So let's go ahead and reduce that down. We're much better off saying root 5 over 3 for our sine value, right? Again, that's just that opposite over hypotenuse. Cosine, same thing, is going to be the adjacent over the hypotenuse. So again, we can call that 2/3. And tangent, opposite over adjacent, which basically, again, if we cancel away those 2's, root 5 over 2, which just tells you that we could have had a much smaller triangle. Notice that each side essentially has a 2 built in there, right, multiplied in. So we could have called this a 3, 2, root 5 triangle, right? We could have reduced all the sides by 2, basically just cutting our triangle in half, right, making it half as large as it would have been before, root 5, 3, and 2. And basically we would have gotten all the same trig values, right? Assuming that theta, again, if we move that vertical line over, would have been the same thing. Now, we also want to be able to find, let me get rid of all those extra lines there. We want to be able to find the other 3 trig functions as well, the reciprocal functions. So again, the reciprocal identities, true statements all the time. The cosecant, right, is just the reciprocal of, or 1 over the sine of theta, right? Since it's the cosecant is really just hypotenuse over opposite, right? It's the reciprocal of the sine, which if we put 1 over the sine, 1 over opposite of our hypotenuse, right? 1 over opposite over hypotenuse, well, we would just multiply by the reciprocal, and we would end up with that statement right there, right? Hypotenuse over opposite. So again, that's why that's called a trig identity. It's true all the time, essentially by definition. Now, the nice part is we don't have to do a lot of work there. All we need to do is take the sine answer that we have right over here, right? Sorry, bad asterisk there, bad star. And we're just going to flip that over. Now, I wouldn't go back to the beginning because we just have to reduce the 2 again. So let's just take our final answer here. And we'll just say 3 over root 5. Now, the problem is we don't like that root in the denominator, so I'm going to go ahead and rationalize, right? Multiply top and bottom. So we get 3 root 5 over 5, and that is a much nicer answer, right? So again, just a good idea to rationalize those answers. Secant, again, let's do the same thing. Again, that's going to be the cosine. Remember that the cos don't go together. So cosecant and sine go together because there's only a single co sort of between them, right? Again, co means width. So I guess the easy way to remember it is the width doesn't mean anything on this. Cosecant goes to sine. Secant goes with cosine, right? It's got one co in the pair there. But again, the nice part is 3/2 for an answer, right? 2/3 flips over, or the reciprocal is pretty easy to find. And then finally, cotangent with tangent. So again, 2/5. But again, if we rationalize, multiply the top and bottom by √5, you've got 2√5/5. And we've got all our answers there. Now, where can we use these trig functions? A couple of easy places. Here's just a couple of simple examples. What if a flagpole is casting a shadow, right? Here's kind of a classic trig problem. Find the height of the pole, again, if the angle of elevation saying from the horizontal going upwards, right? From the horizontal upwards, the angle of elevation to the sun is 50.2 degrees. Well, if theta is 50.2 degrees, right? That's our theta value. What we're looking at then is if we want the height of the flagpole, that's going to be the opposite. And again, we know the adjacent, right? We know that we are 10 meters, right, from that flagpole. Well, opposite and adjacent makes me think tangent. So the tangent of theta will be equal to x/10, which means very simply, if we multiply 10 over to the other side, we've got x equals 10 tangent. And again, theta was 50.2 degrees. So let's just type that simply into our calculators. Now, one thing we're going to want to be careful of on our calculator is that we're typing in 50.2 degrees into a trig function. So notice in my calculator, it kind of shows me up top already, but notice I'm in radian mode. So that's not what I want to be at. I want to go up to mode here. I'm going to go ahead and go down a couple of spots. I want to make sure I'm in degree mode. Because you're typing in a trig function, that mode does matter. So we want to make sure we're in degree mode there. And again, we're just going to type in 10 times the tangent of 50.2. But again, since I'm not labeling that inside of there, my calculator needs to know is that radians or degrees. And notice now I'm in degree mode. So we get about 12.002. Now I know the 0.002 doesn't seem like much, but again, let's be precise, accurate to 3 decimal places. About 12.002 meters. The angle of incline of a loading ramp, again, same idea. Basically, if you picture this ramp here, right? We've got a right angle there. We know that the ramp should be no more than 16.5 degrees. Angle of incline, again, same idea, elevation, incline, the rise of our angle, right, is 16.5. Find the height of the truck bed, or sorry, if the height of the truck bed is 34 inches. So this time we know the opposite. We want to find the length of the ramp. We want to find the hypotenuse. Well, opposite and hypotenuse, that sounds like the sine of our angle, so 16.5 degrees is equal to opposite over hypotenuse. And if I multiply x over to the other side, and then notice sine of 16.5, again, it's just a number. So again, if we want to solve that, x will be equal to 34 over the sine of 16.5 degrees. So very simply, again, we'll head back to our calculator. 34 divided by the sine, oops, got the wrong one there. Delete that. Sine of 16.5, and again, I'm in degree mode, so I'm not worried about the label. But because I'm typing in a trig function, again, that mode does matter. So we're going to be about 119.712. So x equals 117, or was that 119? Sorry, my memory is not so spectacular. 119.712. So 19.712. And again, we're dealing in, notice that it was 34 inches. So what we just found is an answer also in inches. I hope that helps you with, again, right triangle trigonometry. Make sure you watch the other videos if you need to. The next video is going to talk a little bit about special angles, so don't be afraid to watch that one as well. If you have any questions, talk to your teacher. Otherwise, have a great day.